Okay, guys, in this class, we are going to focus with equations that has got rational exponents working on our exponential equations, as we are focusing on equations, but these are exponents. So when we are given to solve typical questions that includes or that involve rational exponents, what you need to understand on this concept is that any number has got its inverse. All right. Any number has got an inverse. There is an inverse of 2, which is the reciprocal of 2. So the reciprocal of a number, like the reciprocal of a 2, it's 1 over that number. All right. 2 as a number, originally as it is the same as 2 over 1. 2 over a 1 like this. This is the original number that we consider a 2 is given as what? 2 over a 1. So the reciprocal of this number is just interchanging of the fraction. So it is going to be 1 over 2. That is the reciprocal of this number. So like I said, every number, as long as you've got a number, it's written as a rational term. So if I'm given 4, I'm supposed to know that, okay, 4 is same as 4 over 1. So the reciprocal of this number 4, which is 4 over 1, is simply the interchanging of that fraction, 1 over 4. So that's the reciprocal or the inverse of the inverse of a particular number. You're talking about the reciprocal or the inverse of a particular term. So when I'm given, let's say this is 2 over 7. Originally, I'm given a fraction, 2 over 7. What is going to be the inverse of 2 over 7 or the reciprocal of 2 over 7? I interchange this. I take 7 up and 2 down, 7 over 2. That's the reciprocal. Okay, why am I talking about this reciprocal? Okay, it follows that a number, the original number, all right, I've got the original number, and its inverse, the inverse of that number. If I multiply the original number to its inverse, always we are going to get a 1. An original number, the original number that you're given, or the original term, the one that you are given in the first place, when you multiply to its inverse, you get a 1. Okay, let's take this. We said 2 is same as 2 over 1. This is 2. And times its inverse. This is our original number 2. Its inverse means we interchange 1 over 2 like this. If we multiply this, guys, we're going to get a 1. Use your calculator, you're going to get a 1. So the inverse, the number to its inverse or the inverse to the number, it gives us a 1. Take any consideration that you can think of, any that you can think of. Minus 2, that is our number. What is the inverse of minus 2? First of all, minus 2 is same as what? Is same as minus 2 over 1. So the inverse of minus 2 is simply interchanging. So it's going to be 1 over minus 2. That's the inverse. So if I multiply this, what do I obtain? Minus 2 over 1 times 1 over minus 2. Seriously, I'm going to get a 1, a positive 1. Whether I'm given minus 3 over 7 as the original number, the inverse of this number is going to be 7 on top minus 3 in the denominator. And if we multiply these two, we are going to get a 1. So why are we talking about this? This is going to help us to solve what are referred to as the exponential equations, that is got rational exponents. By finding the inverse of the exponent. Why? Because we saw that the original number, when multiplied to its inverse, it gives us a 1. So when I'm asked to solve this equation, x to the exponent of 1 over 4 is equal to 3. What I simply need here is to have x, and x is affected. If you check, our x here is affected by what? By 1 over 4. So I want to remove this 1 over 4. So to remove 1 over 4 and remain with a 1 over 4, in order for us to give us a 1, it must be multiplied to its inverse. That's what I said, or its reciprocal, so that we get a 1. The original number to its reciprocal or inverse, it gives us a 1. So what is the reciprocal of this 1 over 4? You simply interchange that. That is going to be 4 over 1. Guys, 4 over 1 is same as 4. It is same as 4. So what we need with this inverse, this is what you're going to do with the reciprocal. We are going to raise everything to the exponent of the reciprocal 4 over 1 to the exponent of the reciprocal 4 over 1. Everything. Remember, it's an equation. What you do on the left-hand side must be also done on the right-hand side. So on the left-hand side, there's nothing that you're going to simplify because you know there's an exponent, which is the original number, which is being multiplied to its inverse. So what are you going to get? You're going to get a 1. So we are left with x to the exponent of a 1 is equal to 3 to the exponent of 4 over 1 is same as what? It is same as 4. So as we can see, we now have x because we understand that any number, when raised to the exponent of 1, it remains as it is, as long it is raised to the exponent of 1. 4 to the exponent of 1 is 4. This is not 4 to the exponent of a 0, which gives us a 1. To the exponent of 1, the number remains as it is. So take note about that one. So meaning to say, we are going to simplify the right-hand side. On the right-hand side, if you simplify, that's 3 to the exponent of a 4, which is going to give us 81. If you multiply 3 4 times, you're going to get an 81, or you can even use your calculator on that simplification. You can even use the calculator for that. That's how you solve this. So the concept of the reciprocal is very, very important, the inverse. So if I'm given x to the exponent of minus 2 over 3 like this, or number 2, I'm simply using the same concept, x to the exponent of minus 2, that's minus 3 over 2. Minus 3 over 2 is equivalent to 8. I want to remove this so that I remain with x. What I need here is to have x, that is to solve. So what is the reciprocal of this? The inverse of minus 3 over 2. We said we simply interchange. So that's minus 2. That's going to be 2 over minus 3. We take this on top, 3 down. That's the inverse, the reciprocal. So with our inverse, we are going to affect each and every exponent. So this is x to the exponent of minus 3 over 2. But the whole of this part is going to be affected by the inverse, the reciprocal, which is 2 over minus 3. Which is the same thing that we are going to have on this 8. It was 8 to the exponent of a 1, but it's going to be raised to the inverse, which is to the exponent of what? 2 over minus 3. But guys, as we know that 2 over minus 3 is the same as what? It is the same as minus 2 over 3. So instead, I can just write this as minus 2 over 3. All right. But here, if you multiply these two terms here, you are going to get a 1. Minus 3 over 2 times 2 over minus 3, you are going to obtain what? A 1, which is equal to, you simplify this. We are now applying your laws of exponents. Like I said, this here is the same thing as writing it as 8 to the exponent of minus 2 over 3. So as we know from our laws of exponents, remember I said a to the exponent of m over n, it gives us the nth root of a to the exponent of m. All right. So meaning to say, with the negative that you are given here, it simply means we have got a 1 over, in this case, 1 over what? 8 to the exponent of 2/3. The negative is no longer there. We are now left with 8 to the exponent of 2/3. 8 to the exponent of 2/3 from this format means the cube root. All right. This is going to be the cube root here. So let us just have it. So it's going to be the cube root from this format. So it's going to be the cube root of 8, everything to the exponent of what? Of 2. So that's what you're going to have. To the exponent of a negative means 1 over. So we are supposed to write 1 over 8 to the exponent of 2/3, which is this part. To the exponent of 2/3, the cube root of 8 to the exponent of what? To the exponent of 2. X to the exponent of 1, like I said, it's x. So that will be 1 over the cube root of 8, which is the number that is going to multiply itself 3 times to give us 8 is what? Is 2. 2 times 2 times 2, that is going to give us what? 8. But everything must be raised to the exponent of 2. So if you simplify this, we're going to have 1 over x is equal to 1 over 2 to the exponent of 2, which is what? Which is a 4. So that is the answer that I'm supposed to obtain if I'm to simplify this properly. So you are supposed to be very, very careful how you are given your questions and how you simplify the typical questions. All right, let us check what we have on question number 3. Is the same thing. I'm not going to answer all of these questions. You need to try as much as you can. On question number 3, we are given x to the exponent of minus 1 over 2 is equal to 7 over 2. So like I said, it is the same approach, the same application of our laws. There is a negative 1 over 2. We want to remove this. We want to remove that. So what is the reciprocal of minus 1 over 2? It is going to be 2 over minus 1. You just interchange. So everything is going to be affected. X to the exponent of minus half, which was originally there, to the exponent of minus 2 over 1, which is the same as 2 over minus 1. It's the same as minus 2. All right? Is equal to 7 over 2 to the exponent of what? 2 over minus 1, which is same as minus 2, guys. 2, same as minus 2. So there, the original term to its inverse multiplied together, we said we are going to get what? A 1. So that's x to the exponent of a 1 is equal to 7 over 2 to the exponent of minus 2. You can simplify from your laws of exponents. To the exponent of a negative means the reciprocal. The reciprocal of this, you interchange negative, the reciprocal. So that is going to be 2 over 7 to the exponent of 2. We have removed this negative, the reciprocal of. All right? So that means x is equal to 2 to the exponent of 2, 7 to the exponent of 2. Everything is going to be affected by the exponent of 2. So 2 to the exponent of 2, it's 4. 7 to the exponent of 2, which is what? 49. 2 to the exponent of 2, 2 times 2. 7 to the exponent of 2, 7 times what? Times a 7. So what are we going to have at the end? That is going to be 4 over 49. So you see, how do they give these questions? You are supposed to be very, very careful, like I said before. So I'm not going to answer all these questions, like I said, but we can check question number 6. We are given x to the exponent of 2/3 on question number 6. X to the exponent of 2 over 3 minus 16 is equal to 0. That's what you're given there. Okay? So if we are to consider this, we are going to see that we have got this as an expression because we have got this term and this term. In order for us to remain to apply that concept, we must remove this term and have it on the other side so that we consider what is on the left-hand side to what is on the right-hand side, not the way that it is. So the first thing was to transpose x to the exponent of 2 over 3. We transpose the negative 16 that we are seeing here to the other side of the equation. It becomes a positive. So that's a positive 16. With this knowledge, use it to answer question number 4. All right? Once you're at this stage, think of the inverse now. What is the inverse of 2 over 3? We've got 2 over 3. Just interchange 3 over 2. So everything is going to be affected. X to the exponent of 2 over 3 to the exponent of 3 over 2 is equal to 16 to the exponent of 3 over 2, which is the inverse. The inverse is the one that is being affected. So it affects both sides of the equation. Where here, if you multiply, you're going to get a 1. And here we use our laws of exponents. To the exponent of a fraction, we are now back to our rational exponents. Remember, if you're given a rational exponent a to the exponent of m over n gives us the nth root of a to the exponent of m. We talked about this. But having the 2 there means the square root. So we're going to have the square root of 16 to the exponent of 3. Everything that you get to the exponent of 3. It means there's a 2 there. The square root, there's a 2. Don't worry. You can even leave that. And take note for the square root of any number. The square root of any number is going to be taken as a plus or minus. The square root of 9 plus or minus 3, meaning to say the square root of 16 must be a plus or minus. So x is equal to plus or minus the square root of 16, which number that multiplies itself to give us a 16. That's a 4. Everything is supposed to be raised to the exponent of a 3. Remember that A positive, when raised to an odd exponent, and a negative raised to an odd exponent, they remain as they are. So that will be plus or minus 4 to the exponent of 3. And what is 4 to the exponent of 3? That is a 64. So that's plus or minus 64 in that case. So take note, whenever you are working with a square root, you are supposed to have the plus or minus. Take note, what does it mean? The square root of 16, we are saying it's plus or minus 4. Okay, 4 times 4, we obtain 16. Minus 4 times minus 4, we obtain 16. So that means it's true. All right? But this does not apply on the cube root of a number. The cube root of a number, if it is a positive, it remains a positive. If it is the cube root of a negative, it remains a negative, not for the square root. The square root is the one that we have got what? Plus or minus. So like I said, I'm not going to answer all these questions. Let us just try a last question, which is on question number 11. So if you've got a challenge, try to answer other questions. There are so many questions. If you have a challenge, let me know on the comment section so that we can work those questions together. All right, so like I said, I'm going to try to attempt question number 11, where we are given 8, that is 8x to the exponent of 3 over 4 minus 27 is equal to a 0. Just like the previous case, we have to transpose. So if you see number 12, they already transposed that for you. So the same way that I'm answering number 11 is the same way that you're going to try to answer question 12. So try as many questions. The same way that you're going to answer question 10, question 8, the same way question 7, the same way question number 9. So try as much questions there. All right. So like I said, if it is like this, we want to properly see our left-hand side and the right-hand side. So we are supposed to transpose this to the other side of the equation so that it becomes a positive there. 8x to the exponent of 3 over 4 is equal to a positive 27. And also there's a number there affecting x. What we need is this part of x, this one. So what is affecting it is the 8. And how is it affecting it is multiplying. So how do you remove the part of multiplication? You divide. The reverse of a multiplication is what? Is a division. So that will be x to the exponent of 3 over 4 is equal to 27 over 8. This is where we are. So from the concept that we talked about, we said we have now, if we are left with x like this, x, that is what we are considering. Find its reciprocal, the reciprocal of the exponent, 3 over 4. That will be 4 over 3, just interchange. So that means we're going to raise this to the exponent of its reciprocal, 4 over 3. This also to the exponent of that same reciprocal of 3 over 3. I mean 4 over 3. So if we multiply exponent, there we're going to get a 1. So x to the exponent of 1 is equal to this whole part raised to the exponent of 4 over 3. From our rational exponent, we said the denominator is going to be part of the root sign. So it's going to be the cube root of this. The cube root of 27 over 8, everything being raised to the exponent of the numerator, which is 4. So the numerator is the exponent, the denominator is the number in the root sign. So that means we've got x is equal to, we need to find the cube root of each number, the cube root of 27, which is 3, the cube root of 8, which is 2. There is no plus or minus for the cube root, no plus or minus. And everything that you're getting here or that you're going to obtain must be raised to the exponent of 4. There's already an exponent there. So let's raise everything to the exponent of a 4. So x will be 3 to the exponent of a 4. You multiply 3 times 3 times 3, 4 times. This is what you're simply having. So that will be 81 over 2 to the exponent of 4. You multiply 2 times 2 times 2 times 2, 4 times. That will be 16. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So this is the value of x that is going to satisfy this equation that we are given under our exponent. So like I said, you have the same questions presented just differently, but same calculations. that you can use. You can use this calculation to answer here a lot of questions. So I want you to try as many questions as possible. And I talked about the idea of the square root. The square root of any number, it's a plus or minus. So whenever you see a square root in your simplification, your answers should be affected or must be affected by what? A plus or minus. So these are the typical questions, guys, from Maison African Motives till we meet again.